So in this video, I will be discussing the differences between three of the most useful and fundamental data types, and those are reg, wire, and the one which was introduced by System Verilog, that is logic. I will be explaining each of them with the help of few examples. So let's begin. So let's begin with reg. Reg is a general purpose variable type which is used to model hardware, and its name is kind of confusing because it is reg, but it does not imply a general hardware register. And reg uses four state values. So for a 1-bit reg variable, it can have values like 0, 1, z, which is also called high impedance, and x, which is known as unknown. And reg can only be used inside a procedural block. So let me demonstrate this with the help of an example. So I will be writing a module of very simple D flip-flop. We'll have an output Q, an input E, and an input clock. So during every rising clock edge, the output will be assigned with the input. So let's run the code to check for any compilation error. Okay, it's fine. Now let me write a small TB just underneath it. I will declare all the reg signals. I will instantiate the module. And I will declare ports using the wildcard. Now firstly, I will write the signal for clock. Now clock will forever toggle with the clock width of, let's say, 5. Now I will write another initial block in which I will provide stimulus to the DUT. So firstly, I will give 1 to the input. Then just to avoid the rest around condition, I will be sampling the output at the nag edge of the clock. And I will use $display. I will just copy paste it. And this time I will assign 0. After that, I will write $stop to stop the simulation. So let's check for the compilation error. The code is fine. Let's simulate it. So here you can see we are receiving the correct output. So yeah, that's it for reg. So it's a general purpose variable and it will store the value till it detects any change when it is presented inside the procedural block. So after this, let's move on with wire. So wire is one of the net type such as war and went, and these net types can have around 120 values, which includes the 4 state values that you can find inside reg. Those are 0, 1, high impedance and unknown, including some other values. Those are known as 10th levels. So unlike reg, wire cannot store values. It can only be used with a continuous assignment. So let me demonstrate this with the help of an example. I will be writing a very simple module of an AND gate. I will declare the ports. Y will be my output and A and B will be my input. I will declare the output to be Y and the input will be of reg type. Now I will write a continuous assignment in which I will assign Y with the AND operation between A and B. Now I will write a test module. I will mention the signals. I will instantiate the DUT and I will use the wildcard declaration, ports declaration. First, let's check for any compilation error. Okay, the code is just fine. And I will begin with my initial block to provide some input stimulus. Let's give 1 to A. I will rather concatenate them. So let's give 0, then I will the $drop for play, output the value of Y. And on the next time slot, I will provide different stimulus. After all of these stimulus, I will end the simulation using $stop. Now I will go ahead and run the Okay, so we have a problem here. I think so. We have a classic example of race around condition. So here you can see that for each time slots, I am using $display, but $display is sampling the values of the Y output even before the change is made to A and B. So to counter that, I will use $stop. So what $stop will do that it executes in the postpone region. So by the time the value is sampled, the value of A and B is already assigned to Y because it operates in active region. So let's begin. I think it should solve the problem. Let's save the code and run it for one more time. So as you can observe on the console that we are getting the right values. So the end between 0 and 0 will be 0, and 0 and 1, and 1 and 0 will be 0 and 0, and only the end between the 1 and 1 will be 1. So yeah, we are getting the correct value. So these are the differences between the wire and the reg data type. The wire can only be used with assign or continuous assignment. It can have around 120 values, whereas the reg variable can only have around 4 data types, 4 reg values. Sorry. And also, assign cannot store the values, but reg can store the values. So sometimes in some of the contexts, this becomes quite confusing. So for that particular reason, system Verilog introduced logic. And now we will go through logic. So for most of the cases, logic replaces both the reg and wire data type. And why I said most, you will find out just in a moment. Like reg, it can store values and work as a general purpose variable for modeling hardware. And also it has a plus side that it can be used for both the continuous assignment and the procedural block. So for that particular reason, it reduces the ambiguity and it is more preferred in system Verilog RTL designs. So let me write a simple system Verilog module to demonstrate the usage of logic. So let's begin. I will be writing a very simple mux module. It will have y output, a and b input. So it's a 2 into 1 mux and a select line. I will declare the data type and direction. The only output is y and it will be of logic type. So for this particular demonstration, I will be using a procedural block. I will use always comb. So just assign y equals to conditional operator in which, depending upon the select, I will either get A or B. So if the select is high, A will be assigned to Y. If select is low, B will be assigned to Y. So it's a very simple logic. So let me compile the code. The code is fine. I will instantiate the DUT and I will do the wildcard port declaration. So I will try to provide all possible input combinations. And at the end of each time slot, I will be sampling the value of y using $stop. Instead of that, I'm just stick with few values. The first case, let's select line to 0. Second case, let's 1. Let's stick with two values because it is out of context with this tutorial. So let's compile the code once more. Doesn't have any error. So let us simulate the code. So as you can see right here that for our first stimulus, the value of the select line was 0. So if we see here, if the select line is equals to 0, B will be picked. So here the value of B was 1. So that's why we are getting 1 here. And here the value of the select line was 1. So here the A was getting picked. So that's why we have 1 here. Similarly, here the value of the select line was 0 and it selected B. And here the value of the select line was 1 and it selected A, which is 0. And you can see it right here. So now I will do a little modification with our DUT just to prove that the logic works with both the procedural block as well as the continuous assignment. So I will make a very quick modification. I will write assign here and I will try to run the code again. And let's see whether it works or not. So as you can see right here that Y is working with both the continuous assignment and the procedural block. It is because it is of logic data type, and unlike wire and reg, logic can be used with both procedural and continuous assignment. So remember the first thing I have said that it replaces both wire and reg for most of the cases, but not for all the cases. And I will prove here why. It is because for some scenarios in which you have multiple drivers to a signal or to a output port, the logic will not work. But for those cases, the wire will work. So let me demonstrate this with the help of an example. So to demonstrate that, I will be writing an example of a tri-state bus. So it will have an enable signal and two input signal, those are A and B, and an output signal Y. So I will declare the directions and the data types of each ports. Enable A and B are our inputs, and I'm declaring everything to be of logic data type. So put logic Y. Now here's the thing. So I will assign two drivers to Y, and you will see it right here. So firstly, if enable is high, Y will get, just a second, it's equals to. So if enable is high, Y will get the value of A, and if it gets the value of 0, then Y will get tri-stated. Similarly, I will assign again. So if enable is high, Y will get tri-stated, and if enable is low, Y will get the value of B. So this becomes very important in the context of communication protocols and their design, in which we will be declaring one of these assigned blocks inside the master and the other one inside the slave. But here, for just for the sake of syntax, I will be demonstrating it using both the logic and Y data type. So first, let's run the code and check for any compilation error. So here you can see that we are getting an compilation error, and it clearly mentions here that Y is driven by more than one continuous assignment, and it's not possible in the case of logic. So this is the only case in which wire is still usable. So logic practically replaces reg in every cases, and it's a true successor of reg. It does replace wire in lots of cases, but for this particular case in which we have multiple drivers for an output signal, logic won't work. So what I will do, I will change the data type of wire to be of wire. Now let's compile the code once again. See, it works. It compiled just fine. So that's the only case in which you will find wire to be useful, and it is still useful in such cases. So these were the differences between logic, wire, and reg. So if you are a beginner and you are writing a code in System Verilog, I will recommend you to use logic for most of the cases and forget reg. It is not usable at all because logic replaces everything that reg can do. But for only such cases, which I have already mentioned here, wire is still useful. So I hope you find this tutorial useful. Thank you so much.